In section 6.2, we're going to look at some more identities, them being the sum and difference identities and the double angle identities. Now, there's a common misunderstanding that many students have when studying identities. For example, if we have the cosine of 40 plus 35, students often are confused and think that that will be equal to the cosine of 40 plus the cosine of 35. So what they actually want to do is they want to distribute cos to both those angles. Well, if we were to check this out with a calculator, the cosine of 40 plus 35 is really the same thing as the cosine of 75. And let's see, does this equal the cosine of 40 degrees plus the cosine of 35 degrees? So if I was to type in the cosine of 75, I would get 0.2588, and if I type in the cosine of 40, it's 0.7660 plus the cosine of 35 is 0.8192, so clearly this is not true. What does the cosine of 40 plus 35 equal? Well, if we were to look at the cosine of 40 plus the cosine of 35, it actually equals the cosine of 40 times the cosine of 35 minus the sine of 40 times the sine of 35. And this is known as the sum identity for cosine function. And so if you take a look here, I have two angles that are being added within a cosine function. And the pattern is as follows. It's the cosine of the first angle times the cosine of the second angle. And notice the sign in the expansion changes to minus. And then it's the sine of the first angle times the sine of the second angle. So there's a specific example with the angles 40 and 35. In general, if we have the cosine of A plus B, it's equal to cos A times cos B minus sine A times sine B. Similarly, it can be shown that cos of alpha minus beta, so now I'm just using Greek letters to represent my angles as opposed to letters A and B. Cos of alpha minus beta is cos alpha times cos beta plus sine alpha times sine beta. So again, it's cos of the first angle, cos of the second. If it's minus inside the bracket, it is plus in the addition, sine of the first angle, sine of the second. And this is known as the difference identity for cosine. The sum and difference identities for sine are as follows. So sine follows a different pattern. So the sine of alpha plus beta is sine of the first angle, cosine of the second, plus cosine of the second angle, or cosine of the first angle, sine of the second angle. And the difference pattern is very similar. Again, note if it's minus here, it's minus in the expansion for the sine identity. And tangent follows this pattern. There are actually two identities here. The tan of alpha plus beta. I just follow the top signs in the expansion, so that would be the tan of the first angle plus the tan of the second angle all over 1 minus the tan of the first angle times the tan of the second, and tan of alpha minus beta would be tan of alpha minus tan of beta all over 1 plus tan of alpha times the tan of beta. So there we have our 6 sum and difference identities for our 3 primary trig ratios. Now, in our first example, we want to rewrite each of the following as a trigonometric function of an, and an means singular, angle. So for example, cos of 110 times the cos of 80 minus the sine of 110, the sine of 80. Notice that this follows the pattern cos, cos minus sine, sine. So this is definitely a cosine expansion. And if it's minus in the expansion, that means that it is plus in the condensed form. So therefore 110 plus 80 would be the cosine of 190 degrees. In the next case, the pattern goes sine cos plus sine cos. So this is an expansion of sine. And because it's plus in the expansion, it means it's also plus in the condensed form. So this would be sine 75 plus 30. So this would be equal to the sine of 105 degrees. Tan 5x plus tan 3x divided by 1 minus tan 5x times tan 3x. This is the sum identity for tangent. And again, this would be tan of the first angle plus tan of the second angle. And if we collected like terms, this would be tan 8x. So here we have shown three different ways of taking the expanded form of a sum or difference identity and writing it as its condensed form. A special case in the sum and angle identity occurs when A equals B. And if we were to expand our sum and difference identity, maybe we should just show that here. Let's say, for example, let's take our sine of A plus B is equal to the sine of A, the cosine of B, plus the cosine of A times the sine of B. Now what they're saying in this example is, or in this next derivation of formulas, what if the angles A and B were the same? So let's say that A equals B. So then I'm really going to have the sine of A plus A would be the sine of A, cos of A plus the cos of A times the sine of A. So inside my brackets here I have 2A, and these are like terms, so I would have 2 sine A cos A, and this would be the double angle identity for sine. Notice in the double angle identity in the condensed form, the angle is twice as big as the angle in the expanded form. Similarly, it could be shown for cosine. Now cosine has 3 double angle identities, and again note this angle here in the short form is double the angle over here, and same thing in tangent, the angle is double in the condensed form as compared to the expanded form. Okay, so now we want to write each expression as a trigonometric function, and now they're giving me the double angle identities. Well, if we take a look at the first one, the only one that goes to sine of an angle, cos of an angle is this guy right here. So in this case, theta is equal to 44, and this is this is sine of twice the angle, while the angle in the expanded is 44, so this would be 2 times 44, so this would be the sine of 88 degrees. If we take a look at the next one, 2 tan 18 minus tan squared of 18, that's the double angle identity for tangent. So this would be the tangent of 2 times whatever the angle is in the expanded form, which is 18. So this would be the tan of 36. And in the third one, it's cos squared of an angle minus sine squared of an angle. And if we look at all of our patterns here, I'll get rid of some of this stuff. The only one that seems to follow cos squared of an angle minus sine squared of an angle is the double angle identity for cos. So this means this is going to be cosine of 2 times whatever the angle is in the expansion, which is pi by 5. So this would be cos of 2 pi by 5. So in these 3 examples, we've taken the expanded form of a double angle identity, and we've written it in the condensed form of the double angle identity. All right, I would like you to pause the video and give these a try. Okay, I hope you've had a chance to look at these. And if we again look at the first one, it goes cos, cos plus sine, sine. So this is definitely an expansion of the cosine, or one of the identities. And remember, if it's plus in cosine's expansion, it's minus in the condensed form. So for part A, this would be the cosine of the first angle minus the second angle. And this, if we can combine like terms, would be the cosine of 53 degrees. In part B, it's going to sine of an angle, cos of an angle, and this is the double angle identity for sine. So this is going to be the sine of 2 times my angle, and my angle in the expansion is pi by 12. 2 times pi by 12 can be reduced to the sine of pi by 6. Okay, there's your first part of your assignment for section 6.2, just practicing expanding and condensing sum, difference, and double angle identities. So give that a whirl, and we will continue with the rest of 6.2 in the next lesson.